We have seen in our discussions of cosmology so far that the big debate between atheism and theism has to do with the issue of creation. And so much of the discussion that occupies arguments today between exponents of science and exponents of theology focuses on this question of creation. And we've already seen that the axiomatic principle for all philosophy, and I believe should be for all science, is the phrase ex nihilo nihil fit. Out of nothing, nothing comes. And I argued earlier on that if something exists now, then there always had to be something in reality, or else nothing would exist today. I stated it the opposite way earlier when I said, if there ever was a time when there was nothing, absolutely nothing, what could there possibly be now? Absolutely nothing. Unless something had the power to create itself. Something had the ability of what we call self-creation, which, if you apply the rules of logic, the formal and deductive side of the scientific method to this concept, we see that it is not only illogical, but unscientific. For something to create itself, it would have to antedate itself. It would have to be before it actually was. It would have to be and not be at the same time and in the same relationship. Sort of like our universe that explodes into being that I poked fun at in our last discussion. Now, as I mentioned also earlier, not everybody who denies creation retreats to some concept of self-creation. There are those who argue for an eternal universe. And I'm not going to deal with that subject here because of the time constraints on us, and because the overarching debate in our day is not between those who speak of the universe's beginning and those who argue that it's eternal, because the dominant viewpoint is Big Bang cosmology that does talk about a point of origin some 15 to 18 billion years ago. I was engaged in some dialogue and correspondence with Carl Sagan on this question a few years ago. And I asked him the obvious question that goes with Big Bang cosmology. If for all eternity, all matter and all energy were compressed into an infinitesimal point of singularity, and then one Friday afternoon at 3 o'clock it exploded, which began the expansion of the universe from this explosion, I asked the question, what caused the explosion? What was there before the point of singularity? Because if this point of singularity was eternally inert, what is the outside force that suddenly acted upon it that caused the mutation, that caused the explosion? And Carl responded by saying he didn't feel the need to explore anything beyond that first dawning moment of creation or to ask any questions about it. And that surprised me because I said the task of science and philosophy, going back to Plato, is to save the phenomena. And what that means is coming up with an adequate, sufficient cause and efficient cause for whatever is. Now, the oldest question of science is the question, why is there something rather than nothing? Because the one thing we know for sure is that we are not nothing. Now, as I've said, most of those who would deny creation and a creator retreat to some view to explain the origin of the universe that is one form or another of what we call self-creation. And we've seen that the idea of self-creation is analytically false. That is, it's logically irrational. So the problem that advocates of this have is to justify a thesis or a premise that is manifestly irrational by some kind of argument. And the argument usually proceeds on the basis of one of two different processes. Those who are knowledgeable about philosophy argue that we don't have to attribute an antecedent cause to an effect, because David Hume, in his critique of causality, annihilated the whole idea of cause and effect. Now, I'm going to devote a separate lecture to that question. The other one, which has enticed more and more people in our day, particularly in the scientific community, is that quantum physics, and particularly Heisenberg's indeterminacy principle, has established now scientifically the possibility of self-creation, the possibility of something coming spontaneously from nothing. Now this, in the early days of the experimentation of quantum physics, provoked a very lively debate between two international giants in the field of physics, Niels Bohr of Copenhagen and Albert Einstein. Let me talk to you a little bit about Niels Bohr. Niels Bohr had a family coat of arms. And the crest of the coat of arms had this Latin phrase written on it. I'll write it down. Contraria, C-O-N, sunt complementaria. Contraria sunt complementaria. What does that mean? Simple English. The family crest was this: contraries are complementary. Now in logic, we have the rule of what is called the impossibility of the contrary, which is basically resting upon the fundamental law of all science, the law of non-contradiction. That something cannot be and not be at the same time and in the same relationship. That is, something cannot be and have its contradictory be at the same time and in the same relationship. Now, here's what Niels Bohr said. He said, quote, "A great truth is a truth of which the contrary is also a truth." It's not just a truth. A great truth is a truth where its contradiction is equally true. Now, friends, that's not simply the end of philosophy or the end of theology. That's the end of knowledge. It's the end of science. It's fatal not only to Newtonian physics, it's fatal to Einstein, and it's fatal to Bohr himself. Carl Sagan has an interesting comment about this statement that Niels Bohr made. Sagan says this: "If this statement were true, its consequences might be at least a little perilous." I think that, although I appreciate Sagan's critique of Bohr at this point, his critique should be written in the Guinness Book of Records for the all-time greatest understatement. He said, if this is true, it may be at least a little perilous. Then he goes on to explain why. Interestingly enough, he appeals to the field of ethics. He cites the Golden Rule, and then he looks at the Ten Commandments, and he said, what do we do with the commandment, thou shalt not kill, meaning thou shalt not murder, if its contrary is equally true? If it's a great truth that men ought not to murder one another with premeditated and malice aforethought, And its opposite is also a great truth. It would mean what? Thou shalt kill. Thou shalt commit first-degree murder. That's what Carl Sagan said causes this thesis to be at least a little bit perilous. But what I'm saying is that if it's true that a premise and its contradiction are both true, it is the end of science. It's the end of theology. Now, I would say this idea has become an infatuation with modern American students. Alan Bloom, in his book, The Closing of the American Mind, has documented this kind of relativism. When I step into the seminary classroom with first-year would-be theologians, clearly the majority of them come there believing that truth itself can be contradictory. We have seen the triumph of irrationality in our thinking. And I'm asking, who is going to stop this avalanche of absurdity? My hope is that it will be the computer industry, because computers, as I understand it, need to have some kind of consistency to be able to function without collapsing. Einstein objected to Bohr's understanding of quantum physics and the indeterminacy principle, and made this lively comment. Einstein said, quote, "God doesn't play dice. If he does," said Einstein, "I would rather be a cobbler or work in a gaming house than be a physicist." Now, his biographer, Nigel Calder, criticizes Einstein for his criticism of Niels Bohr and makes this comment, quote, "God does indeed play dice. He has his gaming tables in every atom and every cubic millimeter of empty space." Now, what in the world would cause sane, intelligent, learned, erudite, sentient creatures to talk like this? Part of it is the climate in which we live that welcomes absurdities. We're living in the theater of the absurd today, and somehow we think there's even something not only liberating but majestic about sailing our ship into the sea of irrationality. And Christians tend to think that there's something pious about affirming contradictions, that it indicates some heroic quantum leap of faith that is honoring to God, though it makes God the author of confusion and makes the Holy Spirit speak with a forked tongue. Never mind, it's heroic in its existential import. Well, let me read a passage that Timothy Ferris writes, summarizing some of the problems involved with quantum physics and with the indeterminacy principle. In general and in simple categories, what has provoked all of this are certain experiments with subatomic particles by which the behavior of these subatomic particles cannot be absolutely predicted with certainty, and they behave in such a way as to astonish the observer. Some scientists have thought that the very presence of the experimenter interferes with the behavioral patterns of these subatomic particles. But the first blush is we can't understand why these particles behave in the way they apparently behave. We have a phenomenon here that no paradigm so far has been able to save. And so it throws everything up for grabs and allows people to talk about self-creation and something out of nothing and all the way. Now, I like that Heisenberg calls it the indeterminacy principle, and that can mean a couple of different things. it would seem to me the humble thing would be to say, we do these experiments, we're astonished at what we're observing and recording. We can't make sense out of what's going on here with the knowledge that we bring to the table. And so when I ask what is causing this action to take place, judiciously I have to bow in humility and say, I don't know. The cause is not yet determined. But we hope with further examination, further analysis, further knowledge, we'll be able to understand what's going on. Now, I think that's an appropriate scientific posture towards mystifying results from experimentation. But if somebody takes the next step and says, well, I know that the behavior of these subatomic particles is caused by nothing, that's when I squawk. And I say, time out, I'm not a physicist, I'm not an astronomer, but I am a logician. And the statement you've just made is not only irrational and absurd, but it is supremely arrogant. Because if I don't know what the cause is for a certain action, how can I ever be sure that there is no cause? To come to that point of certainty, I have to explore every conceivable power that exists in all of the universe. It requires nothing less than omniscience to make a judgment of that type. And so on the one hand, we're making judgments that are irrational, and on the other hand, we're making judgments that are supremely arrogant because we are presupposing that we have explored and understood and penetrated every conceivable possibility. Timothy Ferris, who wrote the engaging work on the history of cosmology concerning the Milky Way, makes this summation. He said, quote, "The more closely physicists examined the subatomic world, the larger indeterminacy loomed. When a photon strikes an atom, boosting an electron into a higher orbit, the electron moves from the lower to the upper orbit instantaneously, quote, without having traversed the intervening space. The orbital radii themselves are quantized, and the electron simply ceases to exist at one point, simultaneously appearing at another. This is the famously confounding quantum leap, and it is no mere philosophical poser. Unless it is taken seriously, the behavior of atoms cannot be predicted accurately. Those who find such considerations nonsensical are in good company." Whew, I'm glad for that last statement. That gives me a little bit of relief because I find the statement completely nonsensical. Now, what's my problem? Again, my problem is not with the data. My problem is not with the experiment. My problem is with the inferences people draw from it and the way they articulate it. Because a person has a PhD in physics does not make that person automatically an expert in linguistic precision. On the one hand, we read here in this quantum leap that an electron simply ceases to exist at one point, simultaneously appearing at another. Let's analyze that. This rapidly moving electron ceases to exist at one point. Now, I want you to observe me. Here I am, if you can observe me, or imagine me if you can't. I'm standing at a particular point, and I'm going to move. Now, when I move, do I cease to exist? No, there's still a continuity to my existence. But do I cease to exist at the point where I just was? Yes, I'm no longer there. I moved. And so to say that a subatomic particle ceases to exist at the point where it was, what's so astonishing about that? Obviously, Ferris wants to say something far more profound than that, because that would be true in any form of motion of any body. But what he says, it seems to pass out of existence and at the same time, simultaneously, come back into existence. Now there's a profound thought. Something ceases to be at exactly the same moment it begins to be all over again. This is creation ex nihilo with a vengeance. This is a violation of the law of non-contradiction with a vengeance. Now, if it says, whew, this thing's popping all over the place, I can't figure out why it disappears here and suddenly reappears up here without transversing the intervening space. Now we have material things moving from point A to point B without ever transversing the space. Now, there is a way to do that. It's the way that Timothy Ferris suggests. It ceases to exist A and pops up again in B. And if that's what's happening, I would grant that that's a possibility. But it requires creative energy to do that. This would be the greatest argument for the existence of God you could ever have. If you have something stopping to exist and, but again, it's simultaneous. How do you know that when it reappears, at the same time it disappears, it's the same thing that disappeared? Do we have a collar on it? Do we have a beeper associated with it? Again, I'm not a physicist, but I'm trying to understand what these people are saying, and the words that they are using and the way in which they are putting them together is nonsense. I would be much more impressed by hearing a scientist say, we have things going on here in the behavioral activity of subatomic particles that boggle the mind. It seems, if you just use the word seem, just use the word appear. It seems to the naked eye that these things are moving from one place to the other without transversing the intermediate space. We know that can't be, but it seems like it. Now we have judicious science at work, and now we have a real conundrum that will actually serve as a prod and a stimulus, I'm convinced, for greater scientific achievement and greater scientific progress. That's what happens when we can't solve problems. We're driven to new solutions, to new paradigms, to new explorations. That's the whole motivating spirit behind science. But for us to get there, we have to stop speaking about chance and luck and nothing.